Hi, in this video, we're going to introduce first hop redundancy protocols. Oh, this is so cool. Okay, so, normally when we think we have a PC here, right? And it's configured with a default gateway. Its default gateway address that it's configured for is the 10.1.10.2. Well, this default gateway, especially in IPv4, is a single point of failure. Okay? Because if this link goes down or this default gateway, this router or multi-layer switch goes down, even if we have a backup here, another router or multi-layer switch, here's the problem. The host has the IPv4 address associated with R1. How do we let this host and all of our other devices that have a default gateway, how do we let them know about R2 and its IP address? It's almost not impossible, but it's not practical, because we either have to reconfigure each host statically, if that's how we did it, or our devices that have static default gateway addresses, we'd have to reconfigure them. We'd have to modify our DHCP server and reboot all those clients. Or we would have to modify the IPv4 address on R2 to be, in this case, a .2. None of these are good solutions, because they're time consuming, especially on any kind of large network. So what's the solution to this? Well, you guessed it. First hop redundancy protocols. Okay, so first hop redundancy protocols, and these are ones like, by the way, we'll be talking about these in a moment: HSRP, VRRP, and GLBP. Oh, the acronyms. I'll tell you what they mean in a moment. But they present an illusion of a single router, single default gateway. Okay, it's actually a virtual router. And ARP will return return the MAC address of the virtual router, typically. So some of them work a little differently, but this is kind of with the HSRP that we'll be looking at. That's how it works. So the physical router will actually forward the traffic that goes to this virtual default gateway. A physical router will do all the forwarding. We'll see how this works in just a moment. Okay, so the redundancy protocol, HSRP, VRRP, GLBP, provides the mechanism for determining which router should take on this active role, which router will actually forward the packets out of the network. Okay, and this is what is known as first hop redundancy protocols, FHRP. Okay, and there's actually three main ones. There's HSRP and HSRP for IPv6, so that's one group, and that's a Cisco proprietary protocol. There's also VRRP, Virtual Redundancy Protocol, for both IPv4 and IPv6, and it's almost identical to HSRP. But then there's another one, Cisco proprietary, that's known as Gateway Load Balancing Protocol, GLBP. We will be focusing on HSRP for now in the next couple of videos. However, VRRP is very close, and GLBP is, well, it's very cool. I'll show you a couple of slides on these before we go. So let's do that now. So first of all, VRRP. It's almost identical to HSRP, Hot Standby Routing Protocol. Mostly the differences are in terminology and slight difference in operation, but configuration and everything is almost identical. GLBP, on the other hand, is a little different. It gives you something that HSRP and VRRP do not. So in HSRP or in VRRP, we might have an active router and a standby router. Okay, so everything in let's make sure you know this is HSRP. So everybody uses the active router as their default gateway. The standby is just kind of waiting there going, do. I'm just waiting in case the active router goes by. So it's not doing anything. Now, there are ways that you can configure load balancing with HSRP and VRRP, but you have to do that yourself and you have to figure out the load balancing, and it's not really easy. GLBP, on the other hand, is quite cool because it actually does the load balancing for you, hence the term Global Load Balancing Protocol. Okay, where you will actually, and I won't go into the details here, but you have a router known as the active virtual gateway, and then you have other routers known as actual virtual forwarders. The actual active virtual gateway, AVG, is kind of in charge. And when devices are looking, do an ARP, say, let's take a look here, they have the same default gateway address, both client 1 and client 2. I'm spending a little time here because it is kind of a cool protocol. We don't really go into it first. If you're looking at this for CCNA, we do in CCNP. But anyway, what they will do is they have configured the same IP address for the default gateway. But here's the difference. When they do an ARP request, say what is the MAC address for their default gateway address, the AVG will respond. And the AVG will respond with the MAC address of an active virtual forwarder, including, it could be itself or it could be one of the other routers. You could have even another one over here. So it will actually do the load balance and says, hey, I'll be your default gateway, so I'll give you my MAC address. But for when it replies to the ARP request from client 2 with an ARP reply, it might give the MAC address of router B. So then client 2 will send its default gateway packets to router B, whereas client 1 will send it to router A. Kind of cool, huh? All right, just want to give you a little, because it is different than HSRP, and VRRP is very close to HSRP. So, so I want to give you a little background on GLBP. Wow, these acronyms. Okay, so later videos, we'll look at the operation and configuration of HSRP. Hope you enjoyed this.